In this video, let's talk about queues. So what is a queue? I believe you all know what it is because you've been in the bank, you've been in the airport. The first person that got into the queue is the first one that got serviced or got into the gate. Therefore, first in, first out. In graphic sense, graphic form, you might be lining up waiting and the queue is not moving until a spot is open. Then the first person, A, is able to get that spot, and then B and then C. The two operations doesn't have a sexy name for it. For them, it's just add and remove. We would use similar example. We add 0 to 4 into the queue, with 0 go in first, and if we remove 5 times, what will happen? We would expect the CL to print out from 0 to 4. Let's see an implementation of the queue.h. The node looks exactly the same. The node pointer is exactly the same. That's using type defined to defined. The class queue has 2 private variables instead of 1. We have the front and the end. The front is pointing to the head basically, and then the end is pointing to the last element. We would need this because the when we add to the queue, we have to add to the end, and so it's easier to have a pointer also at the end, and it's easy to maintain it as well. We overload the extraction operator like in the stack. Basically same number of functions. We have the default constructor, we have the copy constructor, we have destructor, we have add a character, we move a character and return the character, and then we have a boolean to see if the queue is empty. In the main function, we are basically doing exactly the same thing, just using a queue. So we add the word magic 1 character at a time into Q1, and then print out the value, and then we pop from or not pop, remove from Q1 and then add it to Q2 directly, and then see what Q2 has, and then we will copy Q2 to Q3, or using basically initiate Q3 using Q2, and then print it out. So default constructor, I'm not going to go through all the functions this time, but the default constructor, I feel it's necessary because very important to have the null pointer set for front and end. And you can tell me why, right? I don't want to repeat it, but I hope you know. For the copy constructor, it's basically the same like in the stack, because the inside still is a linked list, but because we have an end pointer, so we have to set the end pointer, and that's all. In terms of add, we have the end pointer and add things to the end, because if we try to reverse that, because that's, that one way to do it is to have the reverse the linked list and then do it the other way anyways, and you realize it's actually easier if we add to the end, and so that's why I said it's a major decision. So when we think about this kind of implementation, we do think ahead and see which is easier to do. Let's see. I think things are similar. If front equals to null pointer, front becomes front equals insert, and then n equals insert. So basically the add function is the same like the just adding a node into the function.